Okay, so now let's have a look at the training parameters. As I mentioned earlier, there's a slider bar down here which I would really have associated with the top of the screen, which is the batch size. Now the batch size is basically how many training samples to use before you calculate an update of the parameters. And basically it averages the discrepancy between the predictions of the network and the true labels over this batch size. So the batch size was previously set to 10, that was the defaults. Let's remind you basically of what the graphs look like when we do this training with the defaults. So I'll run the training quickly again, look at the graphs here on the right. You can see basically the behavior of that training with that size. Now let's reduce the batch size to 1. That's the minimum, of course. We're not doing any averaging over the discrepancy over a batch of samples. We're essentially just doing an update for every sample of the training set one by one. Now when we run, have a quick look at the graph here, and you should be able to see that it's a little bit more bumpy, a little bit more irregular, because we're not averaging over the batch of samples. Not a very dramatic effect, but nonetheless it can have an effect on your learning progress. Up here on the top we have a parameter called learning rate. Now learning rate is essentially a parameter that says how big a step to take in the direction of reducing the discrepancy. And we've got a default here which is 0.03. Let's be a bit more aggressive. Let's up that to 10. Let's say, okay, now we're going to take a very big step in the direction we think is going to improve in the performance. Now you'd think that that would be a good thing to do. Well, let's see what happens when we run this. And you can basically see on the graph on the right here, it's making no progress whatsoever. It's basically not learning what it's supposed to be learning. And the reason for that is essentially that it's taking such big strides that it's overstepping where the minimum is. It's basically stepping beyond the minimum of this objective function that the network's trying to minimize. Of course, we could decrease the learning rate to something very, very tiny. So let's do that now. And let's see that run. And you can see the graph on the right, it's basically still doing the right thing, but it's taking a heck of a long time to get there, which is kind of obvious. If you take very tiny steps, you're not going to overstep where the minimum is, but you're going to take a long time to get there. So there's a trade-off. If you pick the learning rate to be too high, you might not learn at all. If you pick the learning rate to be very small, it might take a very long time to train your network. Let's set the training rate back to the default and have a look at some of these other parameters here. We've got a parameter here called regularization. At the moment it's set to none. And regularization is basically given in this demo two forms, but there's a whole lot of different forms of regularization. Perhaps you can look that up on the web if you're interested. The two forms given here are the L1 regularization and L2 regularization, and they're fancy terms for basically saying the size of the weights measured in two different ways. The L1 is just the absolute value of the weights, and the L2 is the square of the weights. So they're rather similar, but they have subtle differences in the performance of the network. And the basic idea here is that if you let these weights get too large in value, then when you do your calculations for the updates of the parameters, you're going to get very large numbers coming out, and it can make the training unstable. We didn't see that here because it was a very simple data set to classify, and it wasn't really all that challenging for the network. But I encourage you to play around with this, perhaps with some more complicated data, and we'll see in a moment how we can complicate the data. It's a parameter that usually is a kind of a second order thing. The learning rate is a much more important parameter to get right, but the regularization can be something you can tweak to get the learning progress a little bit better. Returning down to the bottom left-hand side here, we had a look at batch size here, and we still got that set to 1. Let's set it back to something like 10 or something like that. And let's have a look at this other slider bar here, which is called noise. Now the noise is added to the data. Let me just put this slider bar here, and you can see the effect on the right of adding some of the noise to the data. We can see here that some of the orange dots have now come very, very close or perhaps in between some of the blue dots. The noise in the data basically has two aspects. The first is that it's reflecting the real-world situation where real data has some noise. Things are not perfectly measured and things are not perfectly classifiable into two categories. Just as if we add noise here, there's no clear decision boundary that's going to separate this orange dot here from the surrounding blue dots. But the other aspect of noise is that it's sometimes, and this is more surprising, it's sometimes useful in the actual training procedure to add noise to your data because it tests the network a little bit more. It pushes it a little bit more to generalize a little bit better than from the pure data that you might present to it without noise. Okay, so that's it for now. There's a whole lot of things in this demonstration. Most of them we've covered, but there's a few extra things that you can have a look at, such as if you wanted to, you could have a look at regression problems rather than classification problems. You can play adding with noise and different data sets that the demo gives you. I encourage you to spend about an hour or so, and we'll see you soon.